Alright guys, welcome back. We're going to be solving another question from the second chapter of the Meriam textbook, Engineering Mechanics. And in this one, we have this crank OA, which has the length of 50 millimeters. And we also have the angle theta in the figure. So here's our angle theta, which we know is 25 degrees. We also have another angle beta, which is in here, 55 degrees. And as I mentioned, we have the length of OA. So the question is asking for finding the moment of the force F, which we know is 20 newtons about 0.0. So we're going to use the 2D shortcut that we have for finding the moment. Basically, we have our moment, which would be the cross product of R and F. R is position vector, and basically our R would be any line that connects the point that we are trying to find the moment about, which in here is 0.0, to the line of action of the force. This is the line of action of this force F. Each of these can be our R, but obviously we are trying to go with the R that's easiest for us to figure out. And if we get back to here, the given that we have in this question is the distance from O to A. So that would be our R. But we know that the cross product of two vectors is actually R times F times sine of alpha, and alpha would be the angle between these two. And when we have our angle alpha 90 degrees, we can simply just multiply R and F. So for that, we need to resolve this force into two components, one along n axis. So we have n and t in the question. So if we call this one Fn and the perpendicular component to n Ft. So if we can find Fn and Ft, we can see that the resultant of Fn and Ft would be our force F. So as long as we can figure out these two forces, finding the moment is a piece of cake, because we can see that Fn is passing through the point O, so we won't have any moment from the end component of the F, but the Ft, which is perpendicular to that, will satisfy the condition of alpha is equal 90 degrees. So for moment, we simply have R times F. Our R we know is 50 millimeter, so 50 we're going to divide it by 1,000 in order to get it in meter. And we're going to multiply that by the F, which in here is our Ft. So all we need to do in here is to find Ft. And for finding the Ft, we need some information about the angles. And if we look at this right triangle that I'm highlighting in yellow, we should be able to find one of those angles, because we know from here, let me show it in here. So this is the angle that we are interested, and this angle here is our beta, which we know is 55 degrees. And also we have this angle here, theta, which means if that angle is theta, this angle right here is also theta. And I explained one trick in the previous videos when you have two angles like this, where each side is perpendicular to the other one. These two are the same. We have the same scenario in here. We have these two and these two, each side perpendicular to the other one. So these two angles are the same. So if that angle is also theta, we have the whole angle theta. The question mark in here would be basically theta minus 55. So we have theta minus 55 degrees. So this will be equal to our theta is 25 degrees. If we get back to the question, theta is 25, beta is 55. So 25 minus 55 degrees, which is going to be minus 30 degrees. And this negative sign in here shows that our t is actually between F and this dotted line. But I think because the figure is a little bit misleading, we thought that our ft would be actually to the left of F, but as we can see, because of the angle theta, which is not representative of actual values that we have for the angles, that negative sign shows in here. But regardless, it doesn't matter, negative or positive, because as I mentioned, our ft, if we look at this here, ft would be F cosine of the angle, which we call it question mark. So we know that the cosine of theta is equal to cosine of minus theta. And the reason is that because theta would be the first quarter minus theta would be in the fourth quarter. And in both of this, cosine is positive, so it actually doesn't matter in here. So if that's the case, for finding the moment, one thing I forgot about the direction of the moment, this force is going to make a moment in counterclockwise direction. So we're going to put a positive sign in here, and we're going to have 0.05 times F from the question we know is 20 newtons times cosine of minus 30 or 30, field doesn't matter. So we just have to calculate this. 20 times 0.5 times cosine of 30. And this would be the final answer for us, 0.866 Newton meter. And as I mentioned, the moment would be counterclockwise. And that's the final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.